Everyone, welcome to another episode of Learning sCrypt tutorials. In this video, I'm going to show you a very powerful technique called op push transaction. So we have seen, as we talked about in our last video, we have introduced a concept called sighash preimage, which is hashed and then signed in the Bitcoin signature scheme. So it has 10 fields, and we also showed it mostly consists of the data in the current transaction, that is spending the UTXO with embedded contract. So just to put in a more graphical way, we can show it in another format. So think about, in this case, we have transaction 1 has a UTXO smart contract locked 1 in the first output, and then we have another current transaction 2, have a first input trying to spend that output. So in the preimage, for the sighash preimage, you can see it mostly consists of what's in the red circle here. I mean, there are some minor details, but you can regard it as the sighash preimage consists of the current transaction and also the UTXO it is spending. So what this op push transaction technique enables you is to access the sighash preimage by using a very clever technique. The good thing about the sCrypt is we have wrapped around the technique, so you don't have to understand what's happening inside. You can just use a library function to get the current sighash preimage. And then once you have that information, you can do a lot of advanced contract on top of it. So let's see one example. So here again, we open the boilerplate, which consists of many contracts, and I'm going to show you one contract called CLTV, which is short for CheckLockTimeVerify. So basically what it does is for some UTXO, you can specify a time, which I call the mature time here, before which this UTXO cannot be spent. So in general, this is considered impossible, right? Because usually you can only constrain at the transaction level when using the so-called unlock time for a transaction to limit when a transaction becomes valid, but not at the UTXO level. And also in some other fork of the original Bitcoin, such as BTC, they have to introduce a new opcode called the op CheckLockTimeVerify to implement this feature. And I'm showing you here how this can be implemented without introducing new opcode to Bitcoin script using op push transaction technique. So how do we do it? So as I mentioned earlier, the entire op push transaction algorithm is wrapped around in this standard library function called tx.checkPreimage. And then from outside, you can pass a sighash preimage parameter into any public function. And then if the check preimage, this function returns true, you are sure this transaction preimage is for the current transaction. So once you have the transaction preimage, you can parse it according to the format from this specification. So for our case, we want to get to the 9th field, which is unlock time. And here we also have some wrapper function. We don't have to show all the detail. Basically, this function allows you to extract the unlock time field from the sighash preimage. And then you can say this unlock time has to be no later than the mature time you specify. In this way, you can implement check lock time without introducing any new opcode. So that's it for today. I think I'm going to show you more examples. How do you use or push transaction technique to implement more advanced smart contract in future videos. See you next time.